Hi, very good afternoon to you. It's Jim from maverickstar Observatory and welcome. Guys, there's a lot of talk about this mystery of gigantic jet lightning bursts that reach up to 50 miles into space going around in general on YouTube and other social media. I thought I'd put my take on it, and you know, one of the things that got me when I saw this first image was I thought, you know what, I've seen that somewhere before. The reason why NOAA, NASA and other atmospheric science research facilities are interested in this is because how high it went into space. Basically, it's got the capability of taking out satellites. So now there's a mission planned, I believe, in 2006 to actually study this anomaly and more importantly, alongside, study the effects of coronal mass ejections, or solar storms arriving at our magnetosphere, and how much of that gets through. Well, I've showed you a few times on previous charts when we look at the space environment overview of 2015, I think it was, that we know more cosmic radiation is coming in to our lower atmosphere, and it's those cosmic rays are interacting with the particles and getting smashed, creating subatomic particles like muons that we detect in Canada and down there in Australia and here in the UK. So I've done a little bit of research myself with plasma, because we're looking at lightning at the end of the day. That's what this is. This is a lightning discharge which is not going to the ground like normally, it's going up. It's becoming a more common anomaly than it as, and one of the things is it's very hard to detect. One thing that did catch my eye with this is that they mentioned the actual month and year of when it occurred, but they didn't mention the day of when it occurred. It was May 18. So I thought, that's interesting. Was there a solar storm in May? And I went over to a KP index site that has the data that goes back to 2018, and I think it was on the 5th of May there was indeed a solar storm measuring in the KP index of 6. I'll show you. So here we are on spaceweatherlive.com, and we're viewing the archive of Saturday the 5th of May 2018. You can see from 9 o'clock or 21 hours to 00 hours there was a solar storm in effect. It was the only day in May I could find a reasonable solar storm. So I would say that photo was taken on that day, and I'm going to reveal why very shortly, guys, so just bear with me. I think you're going to find this very exciting, because these guys are still trying to work out all this, but I think they've got an idea. I think it was left out on purpose the day because they didn't want people to make the connection between solar storms and upward firing lightning into space, going 50 miles up, which could potentially destroy satellites. So I just want to show you the mission that's planned for 2006, I think it is. So this is the mission that NASA have planned. I think it is for 2006. You can read up on it if you want. Basically, NASA's Electrojet Zeeman Imaging Explorer project, a mission to explore the electrical currents in Earth's upper atmosphere, has passed a critical development milestone after rigorous reviews, moving the mission from the design phase to the construction phase. Basically, they're going to be looking at these electrojets, which are responsible for producing those beautiful auroras, as they state here in there. You've got time to read it if you want, and time to go and have a look for more information on this. But what I believe they're doing is they're studying the interactions between solar storms now and the upper atmosphere, and I guess why that is because now we are starting to see those lightning bolts come from the clouds, go straight up into space, and of course it poses a danger. What this also shows is that it's proof yet again, even though we don't need any more, that the Earth's magnetosphere is weakening, and as a result more cosmic rays are coming in. As a result, we're getting more weather extremes, and these anomalies are becoming more common. But I want to go back to the picture that we first looked at, because I've got an idea they've worked it out, but they're being very cagey about releasing the information on it. I might be able to just help a little bit with some of the information knowledge I've got on plasma, because lightning is plasma, and you know, we might be able to piece the pieces together ourselves. That's why I thought it was important to get you around, you know, tonight to check this out, because I think it's really important, especially with all what we cover here on Pole Shift News. So let's get on with it. So it's going to get a little bit more exciting for you guys here. So on the left we've got that beautiful picture of the lightning jet going up 50 miles into space, and on the right we've got a video that I've done a few years ago now, where I was seeing of plasma and its charge and the way it reacts to magnetic forces being placed on it. Basically all as I was doing was putting a real huge neodymium magnet at the bottom of the Tesla coil, and I was, by just pushing it back some forwards towards the coil, I was able to slow the amount of tentacles that come off those electrojets, if you like, you know, of plasma. First of all, plasma consists of both equal positive and negative charges, and it's considered the fourth state of matter. First one being solid, second liquid, third gas, and then we have plasma. So we get something into a gas stage, we can then turn it into the plasma stage, and that's what we see here. Lightning strike on the left is plasma. The plasma in a plasma ball is the same thing, it's plasma. They both are the same, but note the colours at the ends. The reason why they're changing colour is because this is the area of discharge. Now I'll run the video while we're talking about this, and you'll see I actually slowed the amount of those tentacles coming down on the plasma ball throughout the video, and I was more interested in the charge pattern on the Tesla coil, and you can see that it is equally divided. And I've showed this comparison with a lot of things, like when we're talking about, you know, magnetism, and it has two polarities. If you put a magnetic viewing film over a magnet, you'll see that it forms those plasma charges on the Tesla coil itself. So how does gas become plasma? Well, Nikola Tesla was the first one to invent a Tesla coil and a plasma ball, and you know, through his research he found that by using high frequencies and high voltages through a series of coils, you could create plasma with some noble gases like xenon, I think argon, and a couple of others. But the main point here is what is taking place in the plasma ball is what we're actually seeing here on the left. But why I believe there was upward flash of lightning towards space was because there was a lot of charge in the atmosphere. Now, when we turn a gas into plasma, we knock out all its ions and electrons from the actual molecules, and when we do that, it becomes a plasma. But what it's trying to do is get them molecules back, and that's what happens when we see a discharge colour at the top of the flash of the bolt of lightning changing colour, or at the same when we look at this plasma ball. What's happening is discharging into the atmosphere, which is a low conductor, and that electric then is able to get back into the plasma, and therefore that beam collapses at that point. It's the same thing as what we're seeing with the lightning. We're seeing it reach up to space, discharge, and then that's it, the show's over. So why is this important? Well, I don't think it was any coincidence that they left the actual day out on the website we was just looking at from the institute that produced this photo, because it so happened there probably was occurring. Okay, I'm speculating here, but I believe that's the day it was occurring. There was a solar storm, and plasma likes to get back those ions that it lost, and it's those very ions that are emitted in solar storms towards our Earth. Now, if we're starting to see this anomaly more often, it's an indication, and we know it's already the case because I've showed you on the environmental overview of 2015 that you know, the sun's in a low solar output, and it's not even got the power to push away the radiation beyond our last planet in our solar system. So the heliosphere is weakened, and so is our magnetosphere weakened, and therefore more of these ions are able to come down closer to the surface of the Earth. And when we have, you know, a lot of this potential energy building up in clouds, it can go either of one way, but it's going to choose where the most ions are so that it can neutralise its plasma. You'll know this is the case if you ever played with plasma balls, that when you put your finger on it, all those little hundreds of tentacles just turn into almost one bolt of lightning, miniature bolt of lightning that goes to your finger. And the human body is a better conductor than the ambient air around the plasma ball, so that, you know, you then make the connection to ground for that you know, electricity to pass through you. But what is also happening is that you are giving back the plasma the lost ions that it had originally. And that's why when we see a flash of lightning like we're looking on the left here, it happens very quickly, because as soon as it discharges, the plasma can no longer maintain a plasma and has to go back to a gas. And that's exactly what we're seeing. But they're getting worried about it because it's now got the potential to knock out satellites. And I think we're going to see a lot more of this as we go on through this magnetic reversal. As the magnetosphere starts to weaken, we're going to see a lot more of this. It's also got the potential to strike aircrafts. And this particular lightning jet that went 50 miles up into space was on 100 times or more magnitude than an ordinary bolt of lightning. So we know why it's reaching out towards space, because it's trying to get those ions so it can then transform back from a plasma to a gas. And we know why it's doing it is because there was very likely a solar storm on the 5th of May 2018, and that's when this photo was taken. But they didn't put the day on there, which is a shame, because we could have said yes, almost for definite, that was the case. So I just thought I'd give you my take on this, guys. I know you like sometimes my opinion on these things, and that's it. You know, it was only through messing about with, mainly through, you know, inquisitiveness, that I was messing about with the plasmas. I was interested in looking how the charge is shared at the base of the on the actual Tesla coil, and of course, with the knowledge of plasma being of equal charges, I don't think that what we're looking at when we're looking at the base of the Tesla coil, the charge being of one polarity. I think that there's the division of the two charges. So I'm hoping that you found this interesting, and we'll be back tomorrow with a Earth Alpha at a glance, and there's a link down there if you want to help support us. A huge thank you to those that did support us yesterday. Again, small numbers of people, you know, we have large numbers of people watching these videos, and you know, I spent the best part of today putting some of these this information together for you guys so that you could see, and trying to explain it in a way that, you know, you could understand on the layman's level. So link down there if you want to help support us. I'll say what I usually do. You have an amazing evening, guys. Take care of your loved ones. Back tomorrow as always. Bye for now.